Okay, how do we go about to solve another typical resultant force question? So in this case, you notice it's good to observe what is given in the question and whether is it labeled into the diagram. Notice there's a mass of 6 kg, so this is my M. Okay, there's a force of 54 Newton. In this case, if somebody is pulling, keyword is pulling or pushing something, this for the 54 Newton force, I can label it as my applied force. So this is the force that I'm applying to move this object. Okay, so it's very important because a lot of students get very confused with this concept of resultant force and even applied forces. So it's good to notice that if it's the original pulling or pushing force, in this case here, it will just be my applied force and not resultant force. Okay, later on we'll explain why. So in this case, there's another friction force here, which is labeled as F. So F is actually my otherwise known as my opposing force. Okay, friction always opposes motion, so it's an opposing force. Okay, and there's another additional information, which is my acceleration, which is A. So it's good to put the A here so that I can know what I need to solve it down. So the question is asking for the value of F, which is in this case my friction. So this question looks a bit tough, but actually we can break it down in a few parts. So you notice once you have this key statement called acceleration is 6, straight away we can recall the first concept, which is the concept of resultant force. F is actually equal to M times A. So with this relationship, I know that my mass is 6 kg, my A acceleration is 6. So with these two information here, 6 and 6, I can find my resultant force, which is 36 Newton. So we go back to this question, what is resultant force? Resultant force is the result of all the forces acting on the object. So in this case, for 6 kg mass, there are actually two forces acting on it. One on the right, which is for the applied force, and one which is opposite direction, which is the frictional force. So I can form another equation called my F. Okay, to make things less confusing, this is F, this is also F. So we put a R here. So this is actually my resultant force. So in this case, my F resultant will be pointing towards the side which has the pulling force. So I take 54. In this case, you notice friction is always opposite direction. So I put a minus sign, and I will minus out my frictional force, which is F. So this is equation 2. So you notice I have one equation which I already found my resultant force, which is 36 Newton. I found another equation relating to all the forces acting on the object. So in this case, using simple relationship, I can equate equation 1 equal to equation 2 because these are the two resultants for F. So in this case, I can put 36 is actually equal to my 54 minus F. So in this case, how do we solve for F? Just bring F to the left and bring 36 to the right. So once I bring it to the right, positive become negative, so I minus 36. So if I have a calculator with me, I press, I'll get 18 Newton. Okay, so this is my final answer. Okay, so if we trace back the steps, you notice that if we can observe and notice that there's information given and we can form two separate equations, okay, we can actually solve it quite easily. So this is the final answer. So my answer will be B, 18 Newton. So that's all for this question.